In this video, we're going to talk about the equals method. I'm starting off with this basic class shape, and it has one attribute, color, and it's got a constructor that accepts a color, basically. It's very simple. It doesn't do anything interesting yet. And so if you've looked through the slides about the equals method and polymorphism, what you'll see is that actually every object in Java implicitly extends the object. So this class right here is the same thing as if I just did extends object. And this object class actually has a number of different methods that are defined in there, and one of the methods that's defined in there is equals. And so what equals does, it's defined like this. It's a public Boolean equals, and it accepts an object O. And so the purpose of this method is for a particular instance of shape, I want to know whether or not it's equal to another one. So it's easy to tell for things like numbers, like 5 is equal to 5, and for strings, the string Bob is equal to the string Bob, and things like that. But this is a way to actually compare objects. Okay? So for example, if I go over here to my implementation class, I could say, all right, if I have this shape S1, which is a shape with the color of blue, and a shape S2, which is the color of blue, presumably I would want S1 dot equals S2 to return true, okay? Because the only attribute in shape is that color, I would assume that, okay, any two shapes that are the same color, those should be the same, okay? Or maybe I would have some other criteria, but the point is that I could relate these objects. So basically the way that you use this method is I'm going to override equals over here in shape. So I'm going to actually provide my own implementation of this equals method instead of using whatever is in that object class. Okay, so basically what I'm going to do is I'm going to compare any shapes that have the same color. I'm going to say that those are equal. Okay, now you'll notice that the argument that comes in here is this superclass object, this implicit superclass that all objects in Java are derived from. Okay, so I actually need to convert this into a shape. Okay, so what I can do is I can do shape, I'll just call it temp equals, and then this is where I do my casting, right? So I'm casting the object that's coming in into a shape. Well, the problem with doing this is that presumably I could try and compare this shape to any other sort of object. So I actually need to first test to make sure whether this object coming in is the correct type of object. Okay, so fortunately there is a method in the object class called getClass. Okay, looks like this. And this actually returns the type of class that this object is, this incoming object is. So what I can do is I can say if this dot get class equals o dot get class. All right. So in other words, if the class of my object, which is a shape, is the same as the class of the object coming in, if that's also a shape, then I can go ahead and proceed to do my cast. So I can do shape temp equals shape O. Okay. And now I can basically, now that I have two objects, I have like the current object, this, and I have this object that came in O that I've now casted to temp, I can compare to see if their colors are the same. So I can say, I can guess I'll do string color1 equals this dot color. So in other words, that's this color right here. And then I can do string color2 equals temp dot color. Okay. And so, because temp is this shape object. And I can say if color1 dot equals color2, return true. So in other words, if the strings are equal, then I'm going to return true. Otherwise, I'm going to return false. Okay? And if the classes don't match, then I'm also going to return false. Okay? So now I have this equals object. So now when I go in here, okay, I can, let me just go ahead and make another shape. Shape S3 equals new shape red. Okay, and if I put in another line of code right here, so I'm going to check S1. I'm going to see if S1 is equal to S2, and then S2 is equal to S3. So if I compile this and run it, you will see that now S1 is equal to S2 because they both have the same color name. And S1 is not equal to S3 because blue is not equal to red. Okay? I'm going to just comment this method out for a second. Okay? All right? So if I use shape like this, then it's going to use the equals method that's defined in the object class. All right, and we have no idea what that does. So you will see that now if I were to run this program, you would see, okay, even though I have this shape blue and this other shape blue, they're not the same. Okay, and so that's why I have to override it. So I have to define what equality means. Okay, and so what I'm saying is that for a shape object, equality means that their colors are the same. Okay? Now, it could be that I have a circle class and I want to compare other things besides their color. Maybe I want to compare their color and their radius. Okay? If I had a lone object that had a principal, interest, and a term length, maybe I would want to compare all three of those things to make sure that those objects are equal. Okay? Now, this code here could be massively shortened, but I just, in order to demonstrate how exactly this is working, I kind of wrote it all out. But this is the basic principle behind what the equals method does. Okay, is it allows us to define a way to compare objects of the same type. So in another video, I'm going to go into some more of the nuances of the equals method, particularly as it relates to superclasses and subclasses. So if I was to, for example, create a circle, which is a subclass of shape, how might I write the equals method? That will be covered in a future video.